Hi, we are the Tinius Olsen tensile testers. Today we will be performing a bending test on an old wrench and plate steel.
Drop forging is a metalworking process that gradually shapes a heated piece of metal called an ingot. It involves forming the ingot with repeated blows from a hammer or die that is raised and then dropped onto the part, flattening it or forcing it into a mold. Depending on the complexity of the part design, the process sometimes requires using several dies in progression. The drop forging process usually produces a close approximation of the finished piece, but additional machining typically is required to bring it within tolerance. Drop forging is widely used throughout the automotive industry in producing various engine parts, gears, axles, and also wrenches, like the one that we used in the test. The dies used for drop forging typically are made of high alloy steel or tool steel. Forging dies are designed to be impact resistant and wear resistant, and they generally can withstand thousands of rapid heating and cooling cycles. Drop forging dies are usually made in two halves. The upper half, called the hammer, is attached to the block that is raised and dropped onto the ingot. The lower half, called the anvil, usually is a stationary die against which the ingot is forced. Open die drop forging is done with dies that do not completely enclose the workpiece. The dies usually are flat, although contoured dies or cutting dies can be used as well. The open design allows room for the ingot to expand as it is hammered to the desired thickness.
The specimen provided to us was a working wrench. We took the specimen to a harness tester and performed a Rockwell harness, and then we found out the harness was 36, 33, and 37 on the C scale. And then we took that value and looked up into the machinery's book, and we found out the specimen was a stainless steel. And after finding that out, we took the specimen to a bending machine, and then we performed the bending procedure. So before performing the procedure, we already had calculated the area of the piston with the help of a vernier calipers, and we found out it to be 1.667 inches square. And after that, we put that specimen into a bending machine, and then the fluid pressure was applied to it, and it bent to a certain extent, and after that it completely broke into two pieces. So before breaking into a couple of pieces, the highest or the maximum pressure it took was 800 psi, and taking that pressure, maximum pressure, and area piston, we could find out the bending force, and we found out it to be 1,333.8 pound force. So as a conclusion, we found out that the stainless steel wrench was kind of a brittle specimen, because it took pressure up to some extent and bent up to some extent, but after that it completely broke into two pieces like any other brittle specimen. So that was all about the stainless steel wrench, and we had another specimen to work on.
One of these specimens in this experiment was a metal bar that weighed 16 ounces. The information about this bar was not given before the experiment, so we had to conduct research on what type of material it was. After research, we concluded that this experiment was a mild steel that showed to have a tensile strength of 60,000 psi. During this experiment, the metal bar was placed in the bending machine. The bending machine applied force to the center of the bar to measure the amount of psi it would take to break the bar. During this experiment, as pressure was applied to the center of the bar just kept bending but did not break. After reaching a maximum of 18,000 psi, the bar was removed. This experiment showed that this material that was being tested is a ductile material. If it was a brittle material, it would have broke at 18,000 psi.